Hi, am I audible? Okay, thank you. Thank you, Ms. Ronalata and the team for inviting me to share my thoughts. And I welcome all the students to this talk. I understand that you have your exams very soon and still you are here attending my talk. I will try to make it useful for you, not the boring one. And if any point of time you have something to share with me, I would encourage that if you have some doubts, some queries which you want to really ask and discuss, you have some confusions regarding the topic like what do corporates expect from a data science candidate or otherwise also anything in general from data science, I would welcome you to raise your queries after I finish my session. So let me share my screen. So basically today we are going to talk about what do corporates expect from a data science candidate. What do exactly they look for? There is too much hype and buzz around these words: data science, AI, analytics, and students everywhere get these courses. Even in their college also they have Python and machine learning courses introduced these days, but they get confusion like what all these fields are, what are the roles they can expect after they finish a course, and what are the challenges, because demand is there but supply is also increasing. Everybody is doing data science course these days, so how to stand out in a crowd, how to grab a good job, and how to really work for a real data science team. So it not be exactly the data science scientist title, whatever title you get, but how to land into a good job where you really enjoy working with data. So I'll give you some pointers here. Today what we are going to talk about, where are the gaps between what do students learn, what do they expect in a job or the market, and what do corporates expect from the students. We always see, not only in the data science area, otherwise also there is always a huge gap between academia and industry. What students learn in their college life, what they expect that after finishing the college I'm going to get this, and what corporates expect from a fresher. So there is a gap between that. So I'll be talking about specifically those gap related to data professionals, data science area, and how you can bridge your bridge the gap on your own. Maybe colleges can also do something, maybe corporates can also do something, but because here the target audience is students, so I would like to tell you something how you can bridge that gap and increase your chances for getting hired. Now, I don't think I need to tell anything about me, because Swarnalata ma'am and other students have introduced me very well. So I'm just a trainer. I am PhD in mathematics. Earlier I was into academics. From last 4 5 years now I'm into corporate training. So I have the experience of both worlds, because I was into academics for quite a long time. I know how academics works, and I'm now training those who are corporates and executives. So I know and I hear from their side of story also. So I would like to give you some insight from what I know or what I have experienced. As I said that I love to contribute to the learning communities, research communities, QA sites. I really love to give back to the society, even though I'm not in a full-time job where I was teaching in academics, but I really love to teach and share my knowledge with others. So these are many platforms where I share my knowledge, and I have my own YouTube channel also, wherein I post videos related to data science. I have so many posts and articles on my LinkedIn profile related to data science, machine learning, statistics, career advice, and so on. I have blog post also, so you may go and check these links later on if you want. And yeah, I'll be having a website soon, because there are too many links to browse, but at a current time I am really active on LinkedIn and YouTube only, but I was active on Quora, Stack Overflow, all these platforms, especially for these technical topics. Now let's talk about few things before you even start about the career gap and all those things. Is data science a right career choice for you? Are you a good fit in that? It's not because others are doing it, I need to do it. So where is the hype and reality? What are the myths around the data science domain? What are different job roles? What are required technical skills? And all these topics I had covered in my earlier talk. So you can see this on my YouTube. I'll share the link also, so you can go back and see, because here in detail I have explained all these points. So I'll not be talking about these points again. I don't want to repeat those topics, but yes, I will give you some more insights which are different from this video. So if you're interested, go and check that video. Also in this video, and there is another video in that series. I have a data science career talk series on my YouTube channel. I had discussed in detail what are the required skills, technical skills, as well as the soft skills for different data science roles. As I said, I had discussed mainly 2-3 different data science related roles, like data engineer, data analyst, data scientist, or machine learning engineer, or maybe software engineer. So what do they do exactly? What all tools they use? What are the skills they need? So these things I have discussed in detail in my previous talks. You may watch them, but you might be already knowing. I know some of you are from computer science background, and some of you are already taking Python course, or maybe some machine learning course, or these days everything is there on Google, although it's very messy, not organized. In abundance, when we have so many things, it's difficult to filter out the related content, but still I believe you might be having some ideas about the tools there which are there in the market, and the technologies, and the topics which you need to study if you are really targeting those roles. So these are the things which I'm not spending too much time about, because I have already covered these skills in my previous talks. But if at any time point you would like me to discuss something, you can really ask after the session is ending. So tools, techniques, apart from that, there are some skills which are often ignored by the students, and they just focus on learning the tools. So some of the skills I had mentioned and discussed there. Now let's talk about how expectation and reality are different. Like usually there is a perception data science means it's a very good golden job opportunity, where it's a white collar job. You will be sitting in your office with a very high configuration laptop and working on a data set which is very neat, clean, and you will be solving a problem, and everybody would be impressed with what you have done, and how much business business insight they have gained. So usually you expect everything to be so neat and clean and organized that you just take your steps there and you reach your ultimate goal, where there is the business profit or revenue, and everybody appreciating the data science person or the team. But in reality, the stairs are not like this. These are like this. You might be knowing this if you are a Harry Potter fan. So Hogwarts and the staircase there, so they keep on changing, and there are so many confusing stairs. So the path of a data professional is always like that. It's messy, it keeps on changing, updating, it's confusing. So you need to find out what is the right path to reach a right location, right? So this was just for fun. I have given you this example. But as a student, as a fresher candidate, what usually candidates expect? They expect a clean data in a CSV file, very nice formulated tabular data. Here I'm not talking about the image and text, all those sort of things where you do image processing on NLP, but the basic machine learning. They also expect that clear data description would be available to us, well-defined objective would be available to us. So we will just pick some of the algorithm, like if it is a prediction algorithm, we will try out starting with linear model as the base model, and then maybe some other models, and we will compare the best model. We will compare different models and pick out the best, and yeah, we will get enough time to do that. We will get enough hardware resources to do that, computational power, and definitely when our model will perform best, it would be a value addition to the business. So usually freshers have this mindset. I'm not sure how many of you are really checking the Kaggle and hackathons there. So if you are participating there everybody is competing to just gain a little bit advantage in the accuracy. If your model is little bit performing better than the other students, so you keep on getting more score in that, and you write that on CVs also and your GitHub profile also, and that gives you an advantage. But that is far from reality. In real life, it is not the case that you will always get a clean data, or the model which is performing best on your data is really going to add some value to the business. So in real life, these things are not usually there. in real life, usually you will be having the messy and incomplete data. So there are some points which you want to know, some information which you need to, solve the particular business problem, but those data points are not available. So you need to go ahead and talk to data engineer team and data analyst team, whether they can collect that data, whether they can compile that data, or whether they can do some feature engineering to come up with those features which you really need. Multiple sources of data, it's not that simple. For example, you are in an insurance domain and you really want to see, like you might be knowing when you see the insurance, maybe vehicle insurance or maybe whatever different sort of insurance, so they compute the risk associated to different profiles of applicants, and based on that risk they charge some premium. So if some person is on high risk, maybe you are doing the medical insurance, so they will check if you are already having some history of disease, or maybe your parents or somebody is having some history of medical disease, or maybe something else you might be having something. So they will try to analyze those things and they assess the risk associated to that person to compute the premium. But it's not that thing that they will just collect your data which you fill in the application form, or they will just collect the data from the hospitals. They need to many times collect data from multiple sources to know more about you. And if they collect data from multiple sources, then there might be some person, some data engineer or analyst who is dealing with this task of having data in different formats, some JSON files, some Excel files, some is there in PDF format, some is there on government portal, some tabular data, whatever data format. So they need to collect those different form of data and uh, combine those to give you the information which you really need to process and make the prediction model. And usually the data description is not always clear. If you join a company, you are new to the company and the domain, so you might not be knowing all the terms, technologies and all the jargons which they use, so technical lingo. So you might need you might face this problem that you don't really understand what is this data. For example, there is a data column which talks about FICO score. There is a data which talks about open credit lines. There is a data, these are financial data. Maybe in HR data, there is a column for absenteeism. So you are not sure about what exactly this column is computing. Then you need to talk to the people who really know about that, and you need to prepare a complete data description, or maybe somebody from your team will do that. But a clear data description, you need to really understand the data and the features, and many a times it's not directly available. You need to talk to people, you need to ask questions so that you understand the data and you start solving their problems. Also, there is one more thing, that usually the objective is vaguely defined, because the industries are now opting for machine learning and AI and data science solution. Big players are already doing it from quite some time now, and they are kind of mature. They know how to leverage the power of data, how to formulate the exact business problem, and where to focus, which problem is really more pertinent to them to address first. But those who are new to the market or data science, every big and small company is now trying to do something in data science. So they might not be aware about limitations and advantages of data science or machine learning algorithms or predictive analytics or dashboarding, whatever. So they just give you vague objective that this is the issue we are trying to solve. So as a data person, you need to understand that what are their objective, what are they trying to say, what are the problems they are facing right now. Out of those problems, which problem is really more important, which you would like to take first. So there can be multiple objective in a single organization, but you need to focus one by one that which problem you are taking and how you are doing so. And as I said, technical jargons. So if you are from data science or machine learning or statistics, you might be knowing accuracy, RMSE, precision recall, ROC curve, these things. But the manager who is sitting there talking about the business might not be knowing anything about these things. Even if you say that I have tested the hypothesis, they will not understand. Similarly, when they will say that I'm looking for this much ROE, I'm looking for cost per acquisition to go up, whatever. So you will not be able to understand their terminology. So there is a huge gap there. And how you can bridge that thing, that you need to talk to people, you need to understand. Definitely you need to do research to understand if you are new to that domain or industry, but you really need to talk to the people to try to understand, and it should be a two-way communication. Also, many times in business there are ambiguous or not very clearly defined definitions of KPI. So that is again a challenge if they are not really sure about what are the key performance indicators. And lack of resources also, like they want to do use the data products to gain something in their business, but they don't want to invest too much in the beginning. They are not ready to take that much risk, because machine learning, if they want to implement and get the product deployed end to end, then it might needs a huge investment in terms of hiring the team, plus in terms of getting the right resources and computational power to the system, plus data collection, data management. So all those sort of things need investment. So many times small companies are not ready to invest that much. They just believe that it's something magic wand of Harry Potter. They will give you a problem, they will give you some messy data with incomplete information, and you as a data professional will do some magic and just tell them that okay, do this, do not do this, and your profits will go up by 20% to 10%, like that. But it's not the case really. So you need to convince people, or people should also understand this resources thing also. Now, you understood the difference between expectation and reality when I'm talking about from the perception of a beginner or a fresher or something who's new to data science, that what issues you face. But it's not just one-sided thing, it's two-sided thing, that corporates also expect something from you as a candidate, and they also feel that they are not finding the right talent many a times. Usually we see demand supply gap, that for a job opening of 5 people there are 5,000 people applying. It happens these days because lots of supply, everybody is doing these courses, everybody is applying those courses. But think from their perspective also. Whenever you see something which is not going in the right direction, try to wear other person's shoes also. When you do that, you will realize how difficult is it for corporates to filter out. Suppose they want to fill one position and they are getting 500 resumes, how challenging is it for them to filter out those things, and because they need to hire one, how they will do that? And also the hiring process, they need to invest too much time. They need a complete team of human resource management. They need a technical team who's taking the interviews, giving you the case studies, and there is some team who is coordinating with the candidates and doing the mail correspondence and everything. There are so many things involved, so they are investing there also their money and their time and their resources. They are investing to hire the right person, and many a times when they hire somebody on believing that he or she would be a right fit, they also invest something on initial orientation and training. Usually good corporate companies, they initially provide you some orientation and training so that you understand their business, their requirement, and maybe you just get a feel of how they do it, and you gel up with the team also. But after doing all these exercises for months, it takes months really, and waiting for the right candidate to join, there is a 3 month notice period also. So if you are already working in some company and switching to other domain, so they do wait for the right candidate sometimes. And after doing all these investment, many times they don't get what they were expecting. So here I am talking about from their point of view what they expect from the candidate, and as a candidate what can you do to really meet their expectation. So as I said, there is a huge gap mostly in what they teach you in the classroom plus versus what they expect you in the corporate. So it's not to target anybody, but in general we see it's not about India, it's not about engineering college or MBA college, it's everywhere. So classroom learning and corporate environment are two different worlds. So there is a huge gap between that. So let's talk about bridging that gap. Now, I had written an article on LinkedIn long back about few basic things which everybody should do. Not a data professional, even if you are targeting for some front desk job, whatever. Some basic things which will help you to increase your chances to get a job, plus which will help you to work when you start working in a particular company or any profile. So some basic things I had mentioned there, and here is the link. These links are clickable, so I'll share my presentation also, and when you will click at this link, you will be able to read that. So these are very generic advice for everyone who is looking for a job. But let's talk about in context of data science. So usually they expect a candidate who has an approach to solve business problem. Because see what they are running a business, a company, if there is a bank, insurance company, a healthcare organization, whatever it is, whatever kind of business they are running, a retail store, online store, whatever, they have some business problems and they want somebody who can help them to solve those business problems. And exactly, not exactly all the business problems, but those problems which can be solved by using data. Because data, they know that these days all the businesses have a lot of data in place, and they have devices to track the data, they have something to collect the data, and you might be knowing everybody is collecting data somehow, so they gather the data. But how that data can be used to give them the solution, give them the insight about their business which can really help them in increasing their profit, or help them in decreasing their cost, or help them in better customer relationship management, or launching a new product, so understanding customer requirement, or marketing their product well, or hiring the right people, or retaining the right talent. Because if there are right people in the company and they fail to retain the right talent, then again it's a customer employee churn problem which they want to reduce. So there are many issues which are really common in almost all the businesses. Plus there are some specific problems. For example, in bank or financial institute, they try to find out the risk, so who may default on credit card or a loan, so they try to minimize that risk, that this person looks like he will default after gaining a loan of this much amount. So either to reject the loan application or to involve a high interest rate on that. Like same thing with the insurance and credit card thing we have talked about. So there are many examples, so many use cases are there which are possible. So they want somebody who can really think and understand their problem and give them some solution, which are data driven solution. They already have expert who are giving them solutions and insights based on their experience. That is okay. But these days they also want to leverage the power of data so that the solution can be more accurate, more appropriate and timely. Right? It's not that somebody is doing manually application checking, that you might be knowing in small banks when they get the application for loan, or in insurance companies also. So there is a manual overwriting work, that there are people who manually check your applications, and if they find something suspicious, they visit and they see if the information provided by the person in the application form is correct or not, how much the person is earning, what are the properties he is owning, if he is owning some other loans or some debt from some other person which he is hiding in the application form. So they do all these manual work. But what companies now want is if we can automate most part of the work. So instead of doing this task for 1 or 2 week or 3 week, can we do it in 20 minutes, 10 minutes, 5 minutes, 2 minutes time? Or yes, if there is any suspicious thing which you need to recheck, definitely you will involve human interaction in that, wherein you talk to them, you ask for more documents, you do verification. But generally, if somebody submit an application which is really clean and the profile is clean, then they are looking for those solutions which can be implemented once. So investment once, but long-term profits, that you are saving your time, money and resources in processing those applications. So there are many business problems and they are looking for somebody who can solve these problems. Another thing is they are looking for somebody who knows efficient workflow management and all these things. So I'll talk about these points basically. So first of all, we have already talked about they are looking for solving some business problem, because ultimately if somebody is in business, what they want money. So they want to save money, they want to earn money, they want to increase profit. Plus, they want to gain more customers. So they want to retain their prior customers. They want to build the relationship with their existing customer. Plus, they want to target the right customer. So these are the issues which they are trying to solve. Now, if I'm not wrong, some of you are already doing something in machine learning, or Python, you might be doing some analytics. Usually, what do you do when you learn these courses, or when you take up a course on data science? You get a data, and they give you some objective that, okay, predict the interest rate, or maybe classify these people into default or no default group. So there, a clean data is given to you. Clean, I mean to say, there might be missing value or some data processing required, but still it's a clean CSV file. It's not that messy that you have in real life. So you get a data set and you get a clear objective. So what you think directly? Okay, if it is a prediction problem, I'll start with linear model as my base model. You do some ED also, you do some charting also, you try to understand the features, and maybe you try to go for random forest boosting or neural net kind of algorithm. And these days there are so many AutoML tool also, so you might be trying those algorithms in the AutoML tools just to get the required accuracy or RMSE or AUC, whatever metric you are using. But remember, those managers don't want to hear anything about this. They just want their problem to be solved. Now, it's your job as a data professional to understand their problem and talk to them, talk to the team, and try to figure out that for this problem, what exactly would be my data problem? How will I be solving this data problem? And when you are talking to them, when you are discussing something, when you are trying to ask question about the data description or any particular thing which they know better than you as a data professional, then you need to be very clear and you need to use the layman's term language so that they can understand. It's not going to benefit you if you are just throwing those technical lingo on them just to show off that I know all these things. They will really not value that. If you tell them that I have applied gradient boosting, or I have applied, there was a new boosting algorithm 4 days back, XBNet. So you just tell them that I have done this, I have done this, I have used this library, my accuracy gain is this much. They don't need these information. What they need is you tell them in layman's term that, okay, this is the problem you are facing, so let me formulate it. What I will do, I will consider this data point, I will try to build a model which will give you this thing, and this way if the model works fine and you implement it, you might save your money in this thing. We will analyze what are the variables, what are the reasons which affect a person to default or no default, so that you can analyze further, you can use this information further to solve your problem. So you need to talk in the language which they understand, plus you need to convert the business problem to a data problem. So if time allows, I'll give you one case study, I'll discuss one case study where you can convert business to data problem, and you really talk in terms of impact you are making with the data science problem, not in terms of your accuracy and RMSE thing. But I don't think we'll be able to cover that. Let's see. Data quality is also very important aspect when it comes to do data science. So I'm not talking about that right now, but I just give you one line that if you are not using right quality of data, your model might be garbage in, garbage out, because it's the data which is the fuel of the model. So there are many aspects to it where poor data quality can affect this. In the last slide, maybe I have mentioned a use case about this, so I'll talk about that. Data leakage, data drifts, these are also problems. And these problems, usually in the beginner level course, you don't study about these, but as you keep on reading more books, as you keep on talking to data professionals, you know about these things, that many times what happens is You have built a model, machine learning model, and that model is performing really well on the training data set as well as the validation and test data set or everything. You feel that, okay, my model is working really fine, whatever metric you are using. Now when you use that model in production, that time your model doesn't work well. So this problem is really challenging problem, because many times you feel that I have built a very good model, I have spent a lot of time tuning the parameters, doing the feature engineering, everything, and now what happens in real life? It is a useless model, it's not giving me the results which I expected. So this can be due to multiple reasons. One reason is that you are using some information from the test data while building the model, which you should not use. So that's why I am really not sure how many of you are knowing scikit-learn. So if you know scikit-learn, that's why it is said that you need to do, just a moment, let me see if I can check the chat here, somebody can reply me. Okay, so you should use the pipelines there to create based on create once and then use those pipelines on any new data set, so that you don't get the information from your test or validation data set while you are building the data science model. If you are really new to this, you have never done data science before, you have never used scikit-learn before or machine learning before, or maybe if you have never heard about data leakage or pipeline, no worry about that. But these are the pointers which you will understand more as you will start looking for those things. But really these things you will not get in curriculum which they usually teach in the courses. So that's why I thought of discussing in brief about these topics. I can't spend too much time on each of these topics because each of these topics is a separate session or talk it can be. So let's not drag too much into that. But yeah, basically data drift is also one thing. Once your model is deployed, suppose you have built a model which can find out if the person's profile is risky for insurance or maybe for bank loan application. Now the user is submitting the application. As soon as the user is submitting the application, that data is there in the application, so that data should be processed and give the yes or no go to that thing, right? And that time, if your model is behaving drastically different or not performing well, then it can be due to data drift also, because the observations which you have analyzed in the training data set were quite different from the data which you are getting right now. So there can be certain changes, like these days after the onset of COVID-19, everything is changed. All the businesses has gone through a drastic change. So it may happen that the model which you have built earlier before COVID, it was working fine. There was no data leakage, it was working fine. But after COVID, things have changed for whatever reason, whatever business you are there. So you are getting something else and your previous model is no more usable. So it may happen. Then data analyst, data engineer, ML engineer, they try to figure out if they can do some changes to their existing model to make it usable. So these are different issues. Project life cycle. So as I said, it's not about just model building. There are so many steps involved in, from where you get data and up to where you get the result in the form of a deployed model. So that is the entire life cycle which you should know about. At least you should be aware about the life cycle, role of different people in that life cycle, and where you can contribute, where you need help, and what all skill set you would like to develop if you are targeting a data related job role. What are the stakeholders involved in a particular business problem? So if you are trying to solve a business problem of reducing employee churn, if you are trying to solve a business problem of identifying risk related to that applications, that some person is likely to default on a loan application or not. So you need to understand who are the team members, who are different stakeholders who are involved in this particular business problem, so that you need to keep on communicating with those team members and you gather more information, not only about the data and the variable, but about the business also. From their experience also, what do they believe, what can be the important thing, how things change even without looking at the data, those who are in the business, they know many things, right? So you need to keep talking to them, and definitely it's a loop. If you are trying to build a product and you want it to be deployed, so everything should be in loop, so everybody should know, and it's a teamwork. Everybody should discuss all these things. They might have different opinions, different views, or different priorities also. Like marketing team is saying that we need more budget to market this product so that we can gain more customer, and the finance team is saying we are already having money crunch, so we should not spend too much on marketing. So these are the things. HR team will say that we need to, project management team will say that we need to hire more people so that we can finish our projects on the given timelines, and HR team might say that we are having trouble finding out the right talent for this team, so you need to manage with the existing team. So different department also have their own conflicts in objective priorities, so to figure out how everyone can work together, so it is again a challenge. And as I said, there are key business KPIs. So you need to understand the KPIs related to a particular thing, like click-through rate, cost per acquisition. These are in marketing. In HR, you might talk about absenteeism, how long the employee is staying with your organization, or employee churn rate, which you want to obviously reduce. So there can be different KPIs in different domains. So you need to find out which is the success metrics which you really want to optimize. Now, as I said about the project life cycle, let me just briefly and very roughly tell you about the project life cycle. That first of all, it starts with a business problem. What business problem you are trying to solve, and after that business problem, it goes to a data problem. So first of all, you need to really understand that this is a business problem which they are trying to solve. And when I talk about business problem, here you need to understand who are the stakeholders involved in that, what are the business KPIs or success metrics which they are really targeting to improve upon, and definitely what are the factors which can impact their particular business issues, or what are the factors which can affect, even change their business problem which you are taking at a time. So data problem, you will convert it to data problem ultimately. As a analytics professional or a data science professional, you will try to see, like if it is a prediction, classification, or clustering, or whatever different sort of algorithms are there, so you will try to figure out that thing. And after you are done with defining a clear objective for your data problem, then comes the task of data collection, and data, obviously data cleaning, data validation, data engineering, all these things which is a job of usually the data engineer. And after that they will do some EDA and feature engineering, and as I said, data validation, feature engineering. So EDA means exploratory data analysis. So somebody will try to explore the data using the charts or the statistical test to understand the relationship between different variables. Feature engineering means in a data set you have so many columns, so you try to look at which of the variables are really important for your response variable, or do you need to change some of the variables, do some combination of those variables. I'm not spending too much time on these topics, but somebody who will prepare the data for you, data prep, data cleaning, everything there. And there would be some person who will really analyze the data, and again maybe after analysis they or he or she might believe that we need more information, more data, and all these processes are iterative. Maybe you can go back to this phase, then this phase, then this phase. Then there would be somebody who would be building the model. So model building is what we learn usually in ML courses, so machine learning model building. And you all know it's a very iterative process. So you build a model, you evaluate a model, you tune a model, cross validation, everything. So it's again an iterative process. You do it multiple times, you build multiple models ultimately, and you come up with a model which you feel is final model. Then once you are okay with the final model, then you give it for deployment. Then somebody who is from engineering side, software engineer or data engineer, they will deploy the model. on in production. And after that also, during the deployment and after the deployment, there is a consistent need to monitor the model. As I said, it may happen that model here was working fine with the data validation, everything, it was working fine, but in future it may happen that the input data which you are getting is really different from this data, different in the sense of pattern distributions and statistical properties. So it's really different data. So in that case your model becomes useless, right? So there is a need for somebody to really monitor this data, who is talking about, who is trying to understand if there is a data drift or model drift, where the model or data is really shifted from what we were seeing till here. So you might need to do go back and collect more data or do some analysis or this and this. So basically there are so many phases in a project life cycle. After that a product is there in the right place, right? So when you see somebody says that in a bank or in a particular organization we have done this automation, or we are now using machine learning or AI to do the job, so it's not a one person job, it's a team. It's not a one day or 1 month job, it's a long and iterative process, and so many success and failures. Sometimes even after doing all these efforts models fail. So it's not 100% guarantees. Plus it required a lot of investment, not only in data collection but data management, data quality, model building, computational power, hiring the team, training the team. So there are so many things, right? So cloud and all those things, so you need to invest a lot. So it's a big thing. So companies should also think about whether they are going for it or not. But as a student you need to also understand that in a course you might be knowing about EDA and feature engineering, analysis, model building, evaluate and tuning, but there are other aspects of it also which affects the model. And as a beginner, if you can't understand these things, it's okay, but as a beginner also you should try to focus on this. This is really really important, that you try to understand the business problem. Okay, so as you will keep on doing problem, keep on talking about people, keep on attending the talks from the expert, it's really a good way to understand from others experience. So it will give you an edge over how you talk in terms of business problem, not in terms of data problem. Now the time is limited, let me just talk about workflow management very quickly. That we all know that we need to write code to do the data means model building part, and usually Python is the go-to tool, but there are so many other languages also which you can do. So whatever language you are using, the work should be reproducible. You might be knowing reproducible means your work should be something like anybody can use your script and it should run on any machine without any trouble. So that is reproducible thing. Even when you ask question on Stack Overflow, you should ask a reproducible question, or any forum you are asking, so that other people can run your code and see where you are getting trouble, so that they can help you quickly. So it is really very important aspect. Those who learn coding should focus on these aspects, because it's not like that you will learn pandas or scikit-learn and you are good in Python. It's not like that. If you are unable to do this, it means you will not be able to share and discuss your work with others. So try to learn these things also. Managing different projects, so many times you might be knowing this is a challenge with Python and many other things, that every day new libraries, new version updates are there. So the code file which was working earlier is now no more working, or maybe there are some changes required, so code breaks between. So you need to be able to manage different projects in different environments, where you know that for this project or for this particular code file what all libraries in which version these are required, and how to handle those issues. Collaboration, so as of now you work individually, you take a data from Kaggle and you solve this, but when you are in office you would be working in a team, and maybe a remote team these days, maybe you are sitting together but everybody is on different system, some Windows, some Mac system, something else, but and some people are in different countries or different locations. So how you will collaborate, how you will share your code, how you will get their code, and not only sharing and getting, at the same time 2 people, 3 people, or more than 3 people working on a same file, and they are making some changes. So version control, collaboration, share, these things are really important. These things also you should try to learn. Maybe start with Git and GitHub, but there are some other tools also. Coding best practices, because usually when we start writing a code, our focus is to finish the objective, that okay, I built a model or I have done the job or objective. But it should be an efficient code, means memory efficient, time efficient, because ultimately your script should run fast. Otherwise it would take much longer time and it would not be usable, because we need solution which run fast and memory efficient. So you need to focus on these things as well. Those who are from technical side and those who love programming should focus on improving these aspects very much. Those who are not from programming, they will learn with time, but they should focus on solving the business problem thing. Communication, everybody should learn in whatever profession they have. I have already talked about the importance of asking the right question. Like your manager is talking about a problem, he is giving you a problem statement or business issue, and he's talking that okay, you people work together and give me a solution, right? Now you should be able to understand what he is saying. If you have some doubt, if even if it feels stupid, you should ask that is it the way, is it the real meaning which he want to convey, or is it something different? You should ask. What happens at the worst case, he will feel that it's a silly question, but no question is silly question. Many times questions gives you some insight, sudden insight, or when you are curious you get to learn more. So you should ask question. If you are in exploratory space or explanatory space, when you are in exploratory means you are exploring the data, you are trying to understand data. There you try whatever you want to do, means you are trying to create some chart, do some test, do some model tuning thing, whatever you are trying, nobody is stopping you from trying, if you have that much time and resource, of course. But if you are in explanatory space, means you need to explain your result to somebody. So you need to understand the difference between two. When you are explaining something, it should be very clear, it should be very concise, and it should be in the layman's term, very simple language, and it should be human readable, right? So these are the aspects you should make when you are presenting a report, or when you are even showing your GitHub or Colab notebook to somebody to explain something. So make sure you take care of this thing. Another thing is telling a compelling data story. So if you have found something, if you want to convey something, so you need to learn the art of efficient data storytelling, wherein you are able to present it to non-technical audience also. Now more about these I have explained in my talk on data storytelling. If somebody is interested, that's a very interesting talk with no technical stuff, just some chart and how you can use those for data story thing. So you might want to check that on my YouTube. And ultimately, yeah, it's a teamwork. So if you are targeting a data role, remember that you need to work in a team, and if you are a team player, it's an advantage. If you are somebody who believes that no, I prefer to work alone, then probably you will face some changes there. It's a teamwork, so you need to learn that also. And in interest of time, I'm going to skip this case study which I was trying to give you, how you can understand a business problem and convert it to data problem. So let's skip that problem as of now. Maybe sometime else we will discuss it, but not now. But why you should focus on fundamentals also? I have given you some things that which you should focus, and I told you should be good at coding, you should be good at workflow management, understanding the business. It's okay, but fundamentals are more important. You might be knowing or you might not be knowing. There were so many blunders or crises in the world because of missing on something on fundamentals. For example, this Flint water crisis, I would encourage you all to just Google Flint water crisis and read about that. It was a story in Flint city in America, that there were some change in from where they distribute water to the residents of that city. They changed the source of water supply, and residents were complaining about the bad taste and smell in the water, but they were ignoring the problem. Ultimately they decided to analyze the problem, why there is issue. So they have collected water samples, done some study, and they reached out to conclusion that there is nothing wrong with the water. So they kept on doing the supply, and it resulted in a crisis. So many people have died. because in the water there was too much increased lead level, right? And why this was the problem, the team who was investing this thing, they have taken the data sample which was not representative data sample. So it's really important. Sampling bias can cause big troubles. Another thing is they have ignored the outliers. So there were outliers, and I see many times beginners just keep on deleting the outlier, or maybe just keep on replacing it with something. So you need to understand the outliers. If you just keep on ignoring, it can cost maybe someone's life in a particular domain, or it can cost a huge amount of money if you are into business. It may sometimes not cost that much, but you need to focus too much on the fundamentals. Regarding outliers, also I have written 4 or 5 details post on my LinkedIn, so if somebody is interested, you can see that. Ozone depletion history, so let's not talk about that. You can Google these things and you can understand that for many years the hole in ozone layer was increasing, and we had ignored that because of the system was automatically deleting the observations which were outliers. Outliers means very low ozone level there, but automatically if you are removing those outliers, and you might invite troubles in that analysis. There are some other blunders also, so I'm not going to talk about that, but correlation causation is related to that. So what I want to convey is that it's okay you talk about business insight, it's okay you talk about getting good at coding part and team player and softer skill, but you must focus on fundamentals also. There are AutoML libraries also, Auto EDA libraries also. Use them to save your time. That's it. But don't just blindly rely on them. You need to focus on fundamentals. You need to understand why you are doing what you are doing. Even is it the right thing to do those things? Some of the insights with the 1 or 2 case studies I have discussed in this talk. It's again on my channel. If somebody is interested, you can see that. And ultimately, what I want to give you that if you are starting with a job search in this domain and you try to reach your dream job, I believe I have given you some pointers where you can improve your profile, what you can add on, how you can do that. It was not a talk where I have discussed about resume building and cover page and making your GitHub profile and doing the projects. So I believe you all know about that, but I think I have given you some insights which will help you to reach where you want to reach. So I think that's enough for today. If you have any doubt, I would like to take those doubts quickly. So if you want to follow me on LinkedIn, there I keep on sharing some quick posts related to data science and all these stuff. And there is a YouTube channel. If you want to know about these things, you can subscribe to that. If you want to collaborate with me or do something, there is some particular thing you want to discuss, you can mail it to me. So thank you for being with me for quite a long time, and any doubt, welcome for that.